Open your books. Open your books to page 288. We're going to talk about quadrilaterals. There's several different kinds of quadrilaterals.
Ms. Lang, is that going to record?
Wait,
Yeah, y'all screen.
what do we do? Has it been on record the whole time?
When I said turn to page 288,
Okay.
we didn't talk about jewelry on there. We were just talking about geometry. Okay, special quadrilaterals. Probably a couple of these you have never heard of. Most of them you have. But the first one here is quadrilateral. What's a quadrilateral have? 4 sides. So to be a quadrilateral, you have to have 4 sides. Then what if you have 2 pairs of parallel sides? What do you call that group or that family of quadrilaterals? If they have 2 pairs of parallel sides, they are called parallelograms. So in the family of quadrilateral, we have a branch that's called parallelograms. They have 2 pair of parallel sides. We also have a branch that only has 1 pair of parallel sides, and that's trapezoid. And then we have a branch that has no parallel sides, and that would be called a kite. If you're a kite, you're a kite. There's no other subdivision. However, if you are a trapezoid, are y'all okay? If you're a trapezoid, you can be a special trapezoid. A special trapezoid has, what does it mean for those little marks on each side? Means they're the same, that they're equal. So this is an isosceles trapezoid. If you have 2 pair of parallel sides, you can fall into several different categories. If you have 4 right angles, you are a rectangle. If you have 4 congruent sides, you are a rhombus. If you have both qualities, if you have 4 right angles and 4 congruent sides, then you are a square. So is every square a rhombus? Is every square a rhombus? Yes. Is every square a rectangle? Yes. Is every rectangle a square? No. Is every rhombus a square? No. Okay, parallelogram is a quadrilateral with both pairs of opposite sides parallel. The next one is a kite. It's a quadrilateral with 2 pairs of adjacent sides are congruent and no opposite sides are congruent. So look at that. The adjacent sides are congruent, but the opposite sides are not. Next, we have a rhombus. It's a parallelogram with 4 congruent sides. And then we have a rectangle. It has 4 right angles. And then a square. It has 4 congruent sides and 4 right angles. And then our last group is our trapezoids. The trapezoid is a quadrilateral with exactly one pair of parallel sides. If that trapezoid has non-parallel sides that are congruent, it is isosceles. Everybody got all that written down? So we know what everything has to have. What qualities, what characteristics each of these have to have. Now all you have to do is prove that these things are parallel, or prove that they are congruent, or prove that they are right angles. How do you prove something's parallel? How do you prove something's parallel? What's the same about them? He said their angle and the way they're going. Is he talking about the amount of slant? Would that be, if they're slanted the same amount, would they be parallel? Is there a mathematical term that tells me how much something is slanted? Slope. So if two line segments have the same slope, then we can prove that they're parallel. How do you prove things are congruent? Congruent things are things that are the same. How would you know that two line segments were congruent? I know you know, just tell me. You could use the distance formula, but you looked in your book to come up with that, because no kid's going to come up and say that. Congruent things are things that are the same what, guys? Length, size. Were those words that were coming to your brain? Were you scared to say them? How do you, okay, let me ask you this question. Right angles occur when there's a 90-degree angle. What kind of lines create 90-degree angles? Straight lines. They're all straight. How do you get them to, what's the intersect? Yeah, when they intersect, they form four right angles. What kind of lines do that? All lines are straight, but I know what you're talking about. When they intersect, there's no slant. Perpendicular. Perpendicular. How do you know something's perpendicular? How do you prove that two lines are perpendicular? Do they have the same slope? What kind of slope do they have, Claire? Flip it opposite. Flip it opposite. Slope. So three things you're going to have to be able to prove. You're going to have to prove things are parallel by proving their slopes are the same. You're going to have to prove things are perpendicular because you're going to have to prove that they have flippant opposite slopes. And then you're going to have to prove that line segments are the same length by using the distance formula. Okay, so let's look at our next example. It says classify by the coordinate method. Determine the most precise name for a quadrilateral with these vertices. So let's plot this thing. -4, 4. Put a Q right there. -2, 9. That's B. 8, 9. What's that, H? And 10, 4. Is A. Connect them. does it look like it is? It looks like it's a trapezoid, but I'm going to have to figure it out. I'm going to have to prove it's a trapezoid. Okay? The first thing you have to do is figure out your slopes. It says find the slope of each side from Q to B. They want you to find the slope. Now Q is located at -4, 4, and B is located at -2, 9. And this is x sub 1, y sub 1, this is x sub 2, y sub 2, and they're using the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And when they plug that in, they get 9 minus 4, which is 5, and then they get -2 minus -4, which you know makes that say plus, so it's 5 over 2. So that slope is 5 over 2. Could you have calculated that slope by counting blocks? Could you have said go up 1, 2, 3, 4, 5, and over 2? Yes. Would have been just fine. Now you want the slope of BH. What kind of line is BH? It's a straight line. I'm looking for something a little bit more specific. From B to H. It's a horizontal line. What's the slope of a horizontal line? It's going to be 0. Let's go through the process here. H is located at 8, 9. So I have 9 minus 9, which is 0, over 8 minus -2, which is going to turn out to be 10. But what's 0 over 10? 0. So this has a slope of 0. Okay. Now HA. A is located at 10, 4. So it's 4 minus 9 over 10 minus 8. So that gives me -5 over -2. -5 over -2. When you simplify it, what do you get? 5 over 2. Is that the same slope as this one over here? Wait a minute. That's +2. No, it's not negative over negative. It's -5 over 2. Is that the same slope as this one over here? No, it's not. It's the opposite slope. It's not the flipping opposite. It's just the opposite. QA. What kind of line is QA? Horizontal. So when you find the slopes there, it's going to be 4 minus 4 over 10 minus -4. It's going to be 0 over 14, which is 0. So you found all the slopes. What do you do next? You say, okay, BH, the one at the top, is parallel to QA, the one at the bottom, because their slopes are the same. HA is not parallel to QB because their slopes are different. One pair of opposite sides is parallel, so that makes it a trapezoid. Now they really think it is a isosceles trapezoid, but what do I have to know about it in order to prove it's an isosceles trapezoid? What's an isosceles trapezoid have that sets it apart from just a regular trapezoid? The non-parallel opposite sides happen to be congruent. So I need to check their length. So how am I going to do that? You have to use the distance formula. So they're going to use the distance formula for QB, and they've plugged it in. The distance formula is the square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. So they have -2 minus 4 and then 9 minus 4. So -2 minus 4 is -2 plus 4, which turns out to be 2, and 2 squared is 4. 9 minus 4 is 5, and 5 squared is 25. So this is the square root of 29. Do you know what the answer to the square root of 29 is? No. We can stick it in our calculator. Our calculator will give us an estimate, but it's not one of those perfect square numbers. So I know that this is the square root of 29. Now, which is the side that I think is going to be the same length as this? HA. So let's work on HA. 10 minus 8 squared, and then you have 4 minus 9 squared. 10 minus 8 is 2, and when you square 2, you get 4. 4 minus 9 is -5, and when you square -5, what do you get? 25. Now look, don't do this. Okay, well it did it correctly. Be sure you know that that's going to square that negative and make it be a positive as well. So I get the square root of 29 over here as well. So are these congruent? Yes. So do I need to be concerned about BH and QA? Are they congruent? I can count their blocks. They are on a grid line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this one's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously they're not congruent. But because QB is equal to HA, that is an isosceles trapezoid. Okay? Any questions on that? No questions? Y'all scared to talk because I got the video going? Are you it's just you're feeling a Monday on a Thursday? Is that what it is? Okay. Using the properties of special quadrilaterals in this parallelogram RSTU, the measure of angle R and the measure of angle S are given. Find the measure of angle X. There's something important about parallelograms that I need to tell you. If you take two of these angles that are adjacent and you add them together, they're going to equal 180. Okay? In a parallelogram, they're going to equal 180. Now, here's what it says here. It's a parallelogram, so ST is parallel to UR. So these angles are, I want you to imagine that this was parallel lines cut by transversal. Okay? So they would be same side interior angles. They're going to equal 180 because if the lines are parallel, the interior angles on the same side are supplementary. So 3x plus 50 is equal to 2x minus 10. Let's combine like terms. 3x and 2x make 5x. 50 minus 10 is 40. Yes.
Would it not be 2x minus 10 be 3x plus 50? Because you just
3x plus 50.
because that's the angle S equals 2x.
Oh, did I get them in the wrong spot? I got them in the wrong spot, but it's not going to matter in the long run. Subtract 40 from each side. 5x equals 140. Divide. What's x equal? 28. If x is 28, can you find the measure of this angle? 2 times 28 minus 10. Okay, so this one's 46. This one's 3 times 28 plus 50. 134. Does 134 and 46 add up to be 180? Okay. Next page. Graph the quadrilateral ABCD with these vertices. Okay. Let's draw our grid on here. -3, 3, 2, 4, 3, -1, and -2, -2. What do you think that shape is? Rhombus, square, rectangle? If it's a square, is it a rectangle? If it's a square, is it a rhombus? How do I prove that? I need to know the slopes so that I can prove that they're parallel or prove that they're perpendicular if you're thinking they're right angles. So let's find the slope here. Down 1, 2, 3, 4, 5, and over 1. -5 over 1 is my slope here. Let's find the slope for this one. Let's see, this was A, this was B, this was C, this was D. Up 1 over 1, 2, 3, 4, 5. 1/5. Are those two flipping opposites? Then I know that's a right angle. Okay. Let's find the slope here. Down 1, 2, 3, 4, 5, and over 1. Down 5 over 1. So if this is -5 over 1 and this is 1/5, that also has to be a right angle. What's the slope at the top? Up 1 over 1, 2, 3, 4, 5. 1/5. So those have to be right angles. Because the slopes that create the corners are flipping opposites, those have to be right angles all the way around my figure. So I know it's a rectangle, it has 4 right angles. Now what did we think we wanted to prove about it? That it was a square. So here's what I need you to do. I need the girls to find the distance of AB and the boys to find the distance of BC using the distance formula. Okay? The distance formula says the square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. Did you get square root of 26 each time? Okay, since all of those are the square root of 26, then this one is a square. If it's a square, what other names can I give it? It's a square. Then it's also a what? Rhombus. It's also a rectangle. It's also a parallelogram. And it's a quadrilateral. Okay. Which name gives the most information? Which is the most specific? Square. Okay, problem 2 says find the value of the variables in the rhombus. What is this? They tell you it's a rhombus, so what information are they telling you about this figure?
All the lines are the same, or the same length, or they're congruent.
All the sides are the same length. So how are you going to use that to solve this? How are you going to find the value of b? 3b plus 2 equals, well, it equals 3a plus 8, but that doesn't help me because it's the same, it's not the same letter. So I need to go down here and use 4b plus 2 minus 2. Thank you. So I'm going to combine like terms. 2 equals b minus 2. I get b equals 4. Is that what you get? And what about a? Five a plus 4 is equal to 3a plus 8. 2a plus 4 equals 8. 2a is 4. A is 2. Questions on this page? In our book, this lesson's on page 288 through 291. So here's what you need to do on page 290. You need to do 7 through 12 all. Let's see. 19 through 24 all. That'll be for Thursday. On Friday, we'll do 14 through 18 even, 25, 26.
Wait, why are you putting that?
In case it snows.
Oh, I'm not doing this. I guess I will.
What did you say, Claire?
Oh, we're on. We're on the video. I guess I will, but.
You won't like it one bit, will you? It's mainly so I'll know what I didn't assign. I want to make sure you do 14 through 18, but I don't want to assign them today.